If you go to a class and your professor tells you something like that, you say to them, "Professor, you are breaking my spirit." You say, "You are draining me of the eagerness I have to learn." That doesn't make you good or challenging. It makes you a bad person. All right, aldehydes and ketones. This an aldehyde looks like. Yes? This is the simplest of all aldehydes. This is called the formaldehyde. Okay, formaldehyde. This is a common name.
Bless you.
Okay?
Bless you.
Thank you.
Now that is a common name, and aldehydes will have the ending al. Because they are aldehydes, they will end in. Hello?
Yeah.
Okay. I guess. And how many carbons is this? 1, 2. And the parent chain here is called ethane, yes? So this is called ethanol. Instead of ethanol, it is called ethanol. Now all aldehydes are in carbon 1. Okay? Now there is different ways of naming weird looking things. This here is called a benzaldehyde. Whoops. What is that called? Is that an aldehyde?
No.
That is not an aldehyde, that is a ketone. And the name for this ketone does not end on ketone, it ends on -one, yes? Or 1. So the name of this is cyclohexane, yes? Cyclohexanone. Cyclohexanone. If it had a substitution on it, you'd have to say where the cyclohexanone is or where the aldehyde is. Okay? So let's say you have something like that. You threw him a bone or something? That is messed up. So what's this? Count the longest chain, yes? 1, 2, 3, 4, 5.
No.
What do you mean?
The
No.
straight line.
That is a chain, but it's not.
That's not the longest.
1, 2, 3, 4, 5, 6. So this is a parent name, hexanone. Okay, hexanone. You have to say where the substitutions are. Here's the substitution, yes?
Yeah.
And there is the other substitution.
So it's
You have to say where the ketone is. So this would be,
3.
3 and 4. So it'll be
where do
3
we start?
to the right. It's supposed to be double bonds.
Smallest
To the right.
smallest one goes to
So 1, 2, 3. So let's say this is called the 4-methyl.
3.
3-hexanol. You have to say where that carbonyl is. Of course, we can have R and S, those sort of things. Do you want to do some of those, or you rather
Yes.
skip? Okay, is that naming good for you?
Mm-hmm.
Good for me, I gotta tell you that. Why don't we do some real stuff? We don't wanna waste time on the simple stuff. I bet you can read that. Now here's a carbonyl. And a carbonyl has a side that is negative and a side that is positive. Which side is negative?
Oxygen.
This is delta negative, while this is delta positive. So this side here will do what? What does this side here like to do? Attack. Attack things that are positively charged. So if you had something like this, H plus, what would happen?
It'll protonate that.
It will protonate this. The electron pair will go and get that H plus wherever it is. Okay? And what it will do is this. And what is that going to do? Now this will be a positive charge on that oxygen. Yes or no?
Yep.
It also has a positive side, and this positive side then does what? This positive side gets attacked by
The nucleophile.
nucleophiles. So if you have a nucleophile, the nucleophile is going to do an attack there. And if the attack there happens, then what you get from that attack is this. The electron pair from there, that goes that way. I have made a mess out of this. Okay, let's do another one. How about that? That was not good. Okay, yeah, the nucleophile attacked it, yes? It attacked it there. Let's do another picture. You know these pictures? Nucleophile is going to attack that positive, delta positive on the carbonyl. The electron pairs are going to go up. What is this going to give you? This is going to give you carbon with the oxygen. And the nucleophile. The oxygen will have what type of charge? Negative charge. That is what happens under basic conditions, but under acidic conditions, that will be protonated. And when the nucleophile attacks it, what you are going to get is OH. Which one seems to you like a better structure?
That one.
This seems to me like a better structure, yes?
Yes.
Because it had a charge which was neutralized by this nucleophile. Okay, a lot of the times an acid is added so you can have this more stable structure. Okay? Now, which ones are nucleophiles?
Negative charge.
No clears. Negative.
Like water nucleophile?
Yes. Weak one.
Water is a nucleophile. What else? Oxygen with?
Negative.
Okay. These are water, alcohol. Can an ether do it?
Yes.
An ether can attack it, but after it attacks it, an ether is going to have how many bonds on it? 3 bonds to 3 carbons, not good. Okay? So those are oxygen-containing nucleophiles. We can have nitrogen-containing nucleophiles, like what? Like this.
Mm-hmm.
We can have nucleophiles like this. We can have nucleophiles like this. If we have anything else, we might have weird products. What else can I have? Can I have, by the way, these are neutral nucleophiles, yes?
Yes.
But I can also have something like that, yes?
Mm-hmm.
And I can also have something like that. Okay, charged nucleophiles and neutral nucleophiles. I can have something containing a sulfur. It could be charged or not charged. So that's an oxygen nucleophiles, nitrogen nucleophiles, sulfur nucleophiles. What other type of nucleophiles can we have? Yeah, yes. Can we have any carbon nucleophiles?
Yeah.
Carbon nucleophiles are these, yes? What do they have next to it? What can they have?
Negative.
This could be from a grain yard. They could just be a nucleophile from something like that. Okay. Let's say we have a hydrate. So let's say that what we have is, by the way, which of these two should react faster, the aldehyde on the top or the ketone on the bottom? Aldehyde on the top is more reactive. Write it down. It's not referring to hydrates, okay? Just write down. Aldehydes are more reactive than ketones. And the reason for that is two things. We want this to be delta positive and this to be delta negative, yes? Now, which one has a greater delta positive? This carbon with two methyls pushing electron density that way, or this one with only one methyl pushing electron density that way?
Oh, the one with one.
Okay, the one with one methyl is pushing only one carbon with electron density. This has two of them. This has that and that. So this will be a smaller delta positive than that will be. This will be bigger because it only has one pushing electron density that way. On top of that, there is steric effects. What is more accessible to attack?
One up top.
The one with one
One,
hydrogen is
yeah.
easily attacked
Uh-huh.
because it's less hindered. This here with these two things here is more hindered. So let's say I have it right. Most of these reactions are under equilibrium. So let's say I have, that. Okay? And what I have is an H catalyst. So that means catalytic amount of H plus, and H2O. Have it. Hinder. That's very clear there, it says hinder.
You're very special.
I am special, right?
I get that one.
She used to anyway, she says I'm not special anymore. Alright, so what is going to happen is, so tell me, what do you think happens?
Carbohydrates, the aldehydes.
So what happened is the nucleophile here, this nucleophile attacked there,
Okay.
and this OH is that OH, and the new water is the other OH, and that is called the hydrogen. This reaction is at equilibrium, which lies to the left. I should have drawn the stereochemistry for this. Which picture do you understand? When he has three of them, that's called Trigonal Planar, yes?
Mm-hmm.
This is SB2, this is Trigonal Planar. What does that mean? That has a top and it has a bottom, yes? Okay. So the attack can either occur from here or from here. Does that look like a carbocation? Hello?
Yes.
Yes.
Yes, it looks like a carbocation.
Yeah.
If you took my class, then you know that if it attacks from the top, it would look like this. Yes? Attack from the top, that stays the same. Mu coming group, that will go to the back, and this to the front. If it attacks from the bottom, it will be bottom bond here. And still to the back, to the front. Yes or no? Now this hydrate thing. You guys want to do the mechanism all right?
Yeah.
Wait, huh?
Right.
So you are going to have this thing. Yes or no? That is the acid. You have this in water, and you have an H catalyst. That means not all of them are like this. Some of them are like this. And you have here electron pairs with a delta negative that is going to attack one of these hydrogens. That's the H plus I showed you from the beginning. Now, what is going to happen to two electrons from this bond here?
I'll go to the oxygen.
They're going to go to the oxygen. Okay? So what we have now is oxygen with the two electrons it had before. Now this is positively charged. You agree, yes or no?
Yep.
Now what's going to happen next is
We have a water. We're gonna
there
take
are water
out that
molecules
place.
around.
Yep.
Water molecule, electron pair is going to attack that. And it's going to be all happiness because that gets attacked and this will become neutral.
Neutral.
Okay, this is the purpose of this H plus catalyst. So when that attacks it, electron pairs from this bond are going to go to that oxygen. New electron pair from before. Now this H, and I am drawing it down here, okay? I should be drawing it like that, but we can skip that, yes? Or you want to do it like that?
Okay.
Which way do you want to do it?
With the
Why are you guys
stereochemistry.
staring at me?
With the stereochemistry.
So
That'd be better.
Why are you guys so serious? You don't want to think about this today? You wanted electrophilic aromatic substitution, didn't you? There's an H and an H. Two electrons from here were used to make a bond, and the two that were not used are there. Now this has a positive charge, yes?
Yep.
Yes or no?
Yes.
And now what's going to happen next is, what's going to happen next? I mean, that's not going to stay like this. I don't
No.
think it stays like that, does it?
No.
You
It
need,
doesn't stay.
you need another water.
Okay, another water molecule. Another water molecule is going to go like that.
Uh-huh.
Get that hydrogen, and the two electrons will go to that oxygen.
Yeah.
Okay? Plus
The acid.
regeneration of that acid catalyst. You want more? More is coming, don't worry. Okay, no big deal. Okay? Let's do it with another one. How about that? You want to do it with another one? So I am going to say H cat and CH3OH. Provide the product and mechanism. So here you provide the product first like I did here, yes? And then you provide the mechanism. And this is mechanism under acidic conditions, yes?
Mm-hmm.
Guys, I'm going to pass around the attendance, okay? Please put the date on the top, retroactive.
From
Okay.
3 weeks ago.
Huh? Retroactively? Oh, thank you, Miss USA. Miss English major. Okay, so you put the date, okay? And I don't know how many dates have elapsed since the last time I did this. I think 1 or 2 dates, yes?
You only did it the first day. Not even.
Not
Yeah, that's right.
Not
You
even.
gave us the favor.
Here, put all the dates from the beginning, pass it around. You don't know? No. I gave it to a girl on purpose. Give it to
That's
her,
not
you know?
3.
Sophia will know. Actually, Maria will know. She's the one that is obsessive compulsive.
I do have a calendar.
I know you do. I remember how you used to tell me, no, when is the test? So I can put it on my calendar. Listen, in 1046, you got over that one, huh?
Today's 5.
What chapter is this here?
21.
Line?
Isn't it? Aldehyde ketones? Was it 18, 19, 20? 16?
Everyone has a different version.
Oh, you got the older version. Because in the newer version it's 21.
What?
Yeah,
21 is
Klein.
benzene.
No, Klein. Klein book. You're talking about the school book. Yeah, no, that's different.
Guys, you did make that summary, yes?
Of the
This chapter
reactions.
spends half of the chapter talking about the reactions to make aldehydes and ketones, yes? Like oxidation. Hello?
Mhm.
So what is this gonna give us here?
We're gonna add the CH3O, alcohol,
OH on one side,
CH3O on the other side.
and what else?
CH3O.
Yes?
Yeah.
That has a special name. The one on the top was called a hydrate, and this one here is called, what is it called?
Okay.
No one read it ahead of time?
Study.
You're studying for what?
That's an ester. I don't know.
This is called a hemiacetal.
Way off. And the acetal.
How was this hemiacetal? This is called the hemiacetal because it has one OH and one of these ether groups. If it had two of these ether groups, what would it be called? Acetal. Okay. So let's do this mechanism for this. Should I? Okay.
Hemiacetal. Is that where they get the word hemi for the cars from?
Maybe, I don't know. Professor, what do you say with
It's not the same.
Yeah, the alcohol and one.
Okay? Now, what do you have here? You have this time. Yes or no?
Mm-hmm.
The alcohol and the H plus catalyst, instead of H3O plus, it will be the
Combine
CH3
them?
with the H plus on it. Is that the same as before?
Yeah.
Same.
Same, but just with the
Before you had an
CH3.
H.
Yeah.
And now you have a
The
CH3.
CH3.
And now this is still going to attack that hydrogen, and
Yep, that's good.
the electron pair is going to go to that. Is that the same as the first step in the previous one?
Yes.
Same step. What is that going to do? That is going to protonate
Coordinate
this
that. And then,
carbonyl.
uh-huh.
Yes or no?
Yeah. Then the water.
Now you have
No, not the
the
water.
CH3 with the oxygen
Uh-huh.
and the hydrogen. What is that going to do?
It's gonna attack the carbon.
That is going to attack the carbonyl again. And the two electrons from here are going to go to the oxygen, forming this stuff. that is now positively charged. Yes or no? What's going to happen next? Tell me.
Another one's gonna come.
Another what? Another what?
Another
Another one of these, right? An alcohol or something that has electron pairs will come and pull this proton off, and the electron pairs are going to go to that oxygen, and you are going to form this.
With the regeneration of that catalyst.
How's that, guys? My opinion is the previous one and this one are the same, and the next one is the same, and the same, and the same. That is under what type of conditions?
Acidic.
That is acidic conditions. If you have basic conditions, would the mechanism be different? No. If you have basic conditions, then the mechanism would be different. You want to do basic conditions?
Yeah.
Sure.
You guys want to do it all, don't you?
Don't touch.
You know what happens? The years that I have left are running out. So let's say this then. Let's say
That's under basic condition.
Yeah.
you try to do it, okay?
You.
Are you Pimple?
Yeah, he looks just like him too.
Mr. 305, huh? That's what we're gonna call you from now on, man. You don't want the fame if it doesn't come with the money, huh? Guys, everybody signed it?
Starting with who?
That's all right. Karen, make sure all the dates are correct, okay? You stepped out when I was talking about this. I don't know what you want to do outside.
Well, you see my dates are wrong?
No? I'm just... Who did it, you or her?
She did.
Oh, she did? How many days did you put, Sophia?
5.
No?
No.
I want to know why it takes so long to write that in.
Because we're paying attention.
You guys will understand then.
Oh. Because if you understood stuff, I mean, like you're writing every dot.
Exactly.
Well, I'm not trying to say it, I'm saying. La Vista, what's going on, man? You look sleepy. What you do this weekend?
Study for again.
Oh, I erased it.
Oh my god.
No, that was
Just don't do
You
the
were
whole.
not, you were
Just don't do
not.
the rest. No, but I got that.
Okay. Guys, I'm anxious. So, what do we have here? Do we have protonation of the carbonyl? Yes or no? This is called protonation, yes? Sometimes some people call it proton transfer. We just call it protonation because that's what's happening, right? The proton is getting attached to this. Do we have this under basic conditions?
No.
No, we don't have that under basic conditions. So what we have under basic conditions is attack. What does the attack? The nucleophile that there is, which is this. This here is an oxygen with a plus next to it. So this oxygen must be a minus. So what is going to happen is that is going to attack that. And when it attacks it, what happens? These two electrons go to the top. Now that will have a negative charge. But this will be neutral. By the way, guys, these are equilibrium reactions, yes?
Yeah.
It's equilibrium. I did not draw an equilibrium arrow there, but there are equilibrium reactions. No, don't check mark. Everybody did check marks.
I didn't. I did mine on purpose.
What did you want us to put?
I mean, but that's what I always wanted. Why you guys changing
Because
this
you
like
didn't say it.
I
90%?
said it every
Hey guys, this is what class is this? Are you taking with me like a sixth class? Fifth class?
No, all of you guys.
No, not all of you. I forgive you guys. This is what I wanted here. There's a square, yes?
Yep.
This is what you do inside the square.
How do we do like that?
Not a check mark. It's okay, you did a check mark. Don't worry about it. Okay?
That you want to do.
Don't worry about it.
Oh, pass it around.
Don't worry about it, okay? I get over it. I will get over it eventually. So, what happens here?
So the action. I'm thinking we'll get to proton. So now you have. That's from the middle. Oh.
Yes. Okay, so now I want this to have, under basic conditions, that may stay that way. But if that is to get protonated, it's going to get protonated from the alcohol.
Yeah.
Okay, it can get protonated. Since let's finish with something neutral. Yes? What is going to happen next is this is going to take one of those. And the oxygen is going to keep the electrons. This will become H, CH3, H. I'm going to erase this, okay? Can I erase this?
It's the same thing.
It is the same thing. Right? The mechanism is slightly different, yeah? I like it with a H plus more. Yeah, but you're going to have both of them. So, let's say,
So Professor Garcia, when you doing this mechanism, you for each one of them you put the equilibrium sign arrows?
yeah,
or?
it's supposed to,
Okay.
it's supposed to be like this.
And they're all to the left.
Excuse me? Yes, the equilibrium lies to the left. So let's say we have want you to draw this like this.
Yeah, different one or?
Yeah, different.
That one's done already?
What?
That one's done?
Yeah, that one's done. I want you to draw them like that. Draw the product like that. Only one attack, okay? You don't have to do both. Wait, that's complicated.
Professor, so how do we know if it's basic or acidic?
How do you know?
Yeah.
Because you are supposed to know that Grignards, what they are.
Basic.
Guys, a Grignard basic or acidic?
Basic.
A Grignard is very, very basic, yes? A Grignard is like CH3 minus.
Minus, yeah.
Everybody's going to the bathroom or what? La viste, what's wrong with you, man?
Now I can taste it.
Everybody's fine?
Guys, it is not an X I want you to put, okay? What I want you to put is a line, not an X. An X means you're not here. So whoever did this, I don't want to call your name out.
My bad.
Martinez Maria. Where is she? Novoa Reinaldo. Where's Maria? She's with Mitch?
Somebody just walked out. That might have been her.
No, she's not here today.
Okay.
Don't you see how I always pick on her and she goes, ah.
Oh, yeah, that's right.
Okay, guys, ready? So, let's say, when I erase this, you guys ready?
Yes.
You want me to draw it on the side or you want me to draw it like before?
It doesn't matter. Switch
Like
it up.
before?
Switch it up. 'Cause he's gonna switch it on.
Like before?
Switch it up. Switch it up.
Karen, where's Karen at? Stop going to the bathroom. What's wrong?
I'm not going to bathroom.
How do you want it, Karen? Like before or the new deal? Can't decide? Why don't we do it both ways then?
Yeah.
You guys trying? Okay? So, let's say you are going to have what here? You are going to have this thing. Because a grain yard is a source of a nucleophile. Okay? And you'll have to know what a grain yard is from the organic one. Okay? So what is a nucleophile going to do? It's a base.
Yeah, it's going to
It is going to attack. What is it going to attack? It is going to attack the carbonyl. And that is going to go that way. If it attacks the carbonyl here, look, I'm drawing both of them together. I want you to realize I don't expect you to draw both of them on the test. It's just one. Okay, I'm going to do it again. There. It attacks there. And this goes, that electron pair from that double bond goes to the oxygen. So what you get from here is this. Yes or no? Any charges?
negative on the oxygen.
Negative on the oxygen.
Negative on the oxygen. Okay.
But where are the wedges and the dashes?
The wedges and dashes, I'm going to do them now. Because some of you wanted me to do it from before. So if this now had a proton source, okay? Let's say there was water in there, okay? Or another proton source, okay? It could be water, it could be something else. What would happen is, this will pull the proton off from a proton source, whatever that happens to be. Is this a hemiacetal?
No.
What did we accomplish here? What type of bond did we create? Or did we make? What type of bond? Carbon bond, yes? This increased my molecule. It's not an oxygen here. It is just a carbon. So I accomplished in making a carbon-carbon bond. Okay, very important. If it had the dash and the wedge, that will be dash and this will be wedge, yes? The dash with the CH3, the wedge with the CH2, CH3. Yes? Now it attacked from the bottom, so I'm going to say it looks like that. The bottom is going to be CH3, and the top is going to be the oxygen with a negative charge, which will pick a proton from somewhere. To form that.
You gotta go, you gotta go.
Of course.
Huh? make any comments that are gonna be everlasting. How much time do we have left? Are you cooking something outside and waiting for it to get ready? What, 30 minutes?
18.
Dang, that's
So you wanna do acetal? Sophia?
Yes.
So let's see. That's what we have, yes? And this is going to happen twice. With an H plus there. You have 5 minutes to try to draw that mechanism. Now, I don't have to teach you all mechanisms, okay? I expect you guys to figure some stuff out. I expect you to make a serious mistake here, but that's okay. Laviste, you want to come do it on the board? If you guys think my handwriting is bad, you should check out Laviste. I don't consider that even handwriting. Be honest, you failed calligraphy, didn't you? Guys, you want to finish class early today?
Yes.
Who's going to PLTL? Raise your hands. With who?
Mitch.
That's it?
That's it.
We signed up for step up, but he flaked on us.
Okay, guys, what's next then? You did it? Show 'em. Very good. Good job, man. You did it right. No, it's okay, you don't understand because you have been studying for the other class, right? That's why I'm only doing the easy stuff today. Okay? So, this is what we have, yes?
Mm-hmm.
And there is a catalyst there, H+. What is going to happen is,
Okay, cool.
let's say that is yes or no? oxygen.
Mhm.
Because the H plus will protonate that first.
Oh, yeah. Oh, now this is.
Okay? And then what is going to happen is, electron pair from here is going to take it from there.
Mhm.
Okay? If you make that mistake, it's fine. If you put H plus by itself. And now what we have is this. You agree, yes or no?
Yes.
Yes? Okay. Their problem with this stuff. No?
Mm-mm.
No problems with this stuff? You can say it. I can say it again. You want me to say it again? The acid will protonate that first.
I didn't
Why?
know that.
Because there is a lot of these. Okay? Don't go to these first and then to that, or maybe they go to that one first. It doesn't really make a difference. Okay? But let's say it goes to that one. This is the way we drew. And now what do we have? We have now we have an alcohol. What is the alcohol going to do? It is going to attack
Attack
because
the
it's
carbonyl.
negatively charged,
Yeah.
not negatively charged,
Partially.
because it's partially negative.
Yeah.
Is going to attack the carbonyl, which is delta positive.
Mhm.
And these electrons from here, since this carbon cannot have 5 bonds,
Go for it.
it will break and the electrons will go to the oxygen. And the oxygen is happy about that.
Every neutron.
You want dash? Or you want to omit dash for now? Do you agree, yes or no?
Why did it go off to the side and not down the middle?
Confusing. It doesn't matter if it's on the side or down. I have been putting it down, but I wanted to do the dash thing, so I could have put this a little bit like that and then dash and wedge. I'm giving it to you in another way. What do they call that? Muscle confusion, right? Is that what they call it?
Yeah.
Can you imagine? You heard those guys talking about muscle confusion, yes? How do you confuse a muscle? It's like,
Change it up, switch it up.
you give them chemistry, right? Confuse a muscle. That's amazing. You're not confusing the muscle. That's a lie. Now what?
Well, now you have a positive.
That's
Now
positively
another
charged, yes?
one to the contact.
That's positively charged. Now we're gonna have a situation here in which that positive charge has to go away. Yes? Something is going to pull it away. Okay? What can pull it away? CH3OH.
Yeah.
Yes? So let's say that CH3OH did.
Uh-huh.
Pulls it off. Electron pairs goes to that oxygen. You agree?
Yes.
And you have this from before. Now this oxygen is neutral. So far that looks like what?
No, what we did before.
What we did
Did
before,
before, the
that's
same
right.
thing.
This is a hemiacetal, yes?
Mhm.
That's a hemiacetal. It continues
Until we get it over.
until we get another one. So, but before then, we need to develop, and this is where I think you could have made the mistake. This is where, how does it leave? Well, it leaves by making a good leaving group. And the good leaving group here will be water. Very good. So we are going to have a CH3O. Yes or no?
Mhm.
We had this from before. We had this from here. Yes or no? This is from this stuff. And what's going to happen now is water is going to get that proton and is going to form this with a positive charge. You agree, yes or no?
Yep. And I can leave. And then
And then just
form
have
a
it
color
just
for that.
Hmm? Now, what is weird is going to happen next. Okay? So what happens is the water leaves. Yes?
Yeah.
That makes a positive charge here. Good or no?
No.
Not so good.
Yeah.
Not so good. But luckily, what we have here next to it is
Resonance.
the pair of electrons which are going to make a double
Double
bond
bond.
to this carbon. So as the water bounces, dips, then a double bond is formed in there. Which one didn't you understand? But you gotta ask. Oh, you understand? Oh. Okay. Now what happened? The water left, and now we have this business, yes? Yes or no?
Yep.
A carbon with a double bond to the oxygen, and this oxygen has what in it?
CH3.
CH3 and one lone pair. That oxygen is positively charged. And now that looks again like what? Like a carbonyl, yes?
Yeah.
That can undergo another nucleophilic attack, yes or no?
Mm-hmm.
Another nucleophilic attack by so the oxygen is going to attack that, and what's going to happen to this two electrons from here?
I'll go to the oxygen.
It's going to go to the oxygen. And what you are going to get is that's what you're going to get. And O with a hydrogen, lone pair, CH3, is positively charged. Yes or no?
Yep.
It could have gone on the top too, right?
What?
It could have gone to the top.
Yes, it could have.
Why this one has two minutes
What? What do you say? What?
left? Why this one has 2 minutes left?
Why? God made it that way, man. Bet money that if I spend time here, you know, I stopped at the Hemiacetal, so that stuff would be easy for you. I did 3, and now I do this one last. I expect everybody to be able to do this in 2 minutes on the test.
You're right.
Now what happens next is,
Abstract the hydrogen.
Oh, keep going.
yeah.
Excellent.
Alright, now you need to take out the H.
That needs to go, yes?
Deprotonate. It needs to be deprotonated.
The oxygen goes that way. I mean, the oxygen gets the lone pairs. And that is called the acetal.
Okay.
Plus whatever. There's water in there. It's... How do you like that one?
Tracy.
Okay, you don't know it today, but for next week you gotta know it, okay?
That's not-
Guys, I am showing you the mechanism I am going to give you on the test things you've never seen before, okay? And I expect you to be able to do this based on the rules that I have explained to you, which are the same and the same and the same. Remind me to talk about this next class, okay? Check this out. What's that?
Hydride.
That is a hydride. That is another what?
But it's a base.
Nucleophile.
Nucleophile.
Very
So
strong.
we're gonna attack it with that nucleophile next time, my friends.
Signing off.
No, not Thursday.